Shall we start, sir?
Yes, I am ready actually.
Okay. Good morning, sir, and good afternoon to all my dear student friends. Respected Director of the Institute, Dr. P.V. Kadoli, sir, Head of the Electronics Department, Dr. L.S. Anmode, Madam, today's speaker, Mr. Sourabh Kulkarni, System Engineer, Dynamics, Germany, Coordinator of this event, Professor Vinod Kumbar, sir, and Professor A.V. Shah, sir, all my faculty colleagues, dear student friends, on behalf of Electronics Department, I welcome you all again for today's session under technical webinar series, Recent Trends in Electronics Industry. The rise in global competition has prompted institute to devise strategies to have talented and innovative workforce to gain competitive edge. The technical webinar with six young enthusiastic personalities expert lecture is nothing but the efforts taken by the institute in this direction. Competition and job sector is rising exponentially and securing entry level job is very difficult as the students passing out from technical institutions lack the experience skills required by industry. The Department of Electronics Engineering is conducting an expert lecture series on recent trends in electronics industry to bridge the gap between curriculum and industry requirement at global level and create competent professionals for industry. Our today's speaker, Mr. Sourabh Kulkarni sir, and they are going to guide us on the topic opportunities in Europe and current trends in electronics. First of all, I
I
request
request
Professor
Professor
Vinod
Vinay Kumar sir to introduce our today's speaker, Mr. Sourabh Kulkarni sir.
Kumbar sir,
Kumar,
please.
Uh, our today's speaker, Mr. Sourabh Kulkarni, sir, is working as a development engineer at Dynamics, Germany. He has 4.0 years of extensive work experience in the sensor characterization, NDR gas sensing technology, NR spectroscopy, data analysis using Python. At Dynamics, he is responsible for sensor product development for Dynamics OEM customers in NDR gas analysis and flame detection, etc. His daily tasks involve characterization of optoelectronic components, prototyping, qualification of customer products, as well as assisting the sales team with gas sensing know-how. He has co-developed Trinamics handheld NIR spectrometer. He has done his bachelor's degree from VIT Pune in Instrumentation and Control Engineering in 2014. He has completed his master's degree from Chemnitz University of Technology, Germany, in micro and nano systems. He is passionate about conducting educational awareness workshops, guest lectures, webinars, and seminars. So it's our pleasure to have such an eminent personality joining us today. Thank you, sir.
Thank you, sir, for the nice introduction.
Uh, sir, I request now to start with your presentation.
Okay. So, is my presentation visible now? Is it visible, the slides?
No, sir.
No? Okay. Uh, yeah, now
Fine.
it should be visible.
Yes, yes.
Yes. Okay, so I thank the Institute DKT for giving me this opportunity, and it's my pleasure to be on this series today. Especially when I was in my engineering years, I felt especially that this kind of introduction, like what's going to happen in future and why are we doing engineering, what we should do ahead. I and all my fellow mates, we felt that this was lacking, and so I see this as an interesting opportunity for all the students. So, as rightly said, I'm Sourabh Kulkarni and I'm working as a system engineer in Trinamics GmbH in Germany. And yeah, I did my bachelor's in VIT in instrumentation. Then I got an opportunity through campus placement to work with Emerson, and I worked there for 1.5 years. But somehow, when I was studying there, when I was working there, I felt like the lack of motivation, like why I studied engineering and what I want to do in future. And then I had worked on one industrial project during my third year. So that was about a smart micro sensor. It was basically an accelerometer, and I had to just program it to see the motion of the shock absorber. It was for one of the company in my hometown, and that got me quite intrigued in this micro sensors and microelectronics topic. So I started researching what I can do with this, how I can learn this, and then I became aware of this micro systems and microelectronics. So that's how I landed in Germany to do my masters, and now I'm working with Trinamics in, yeah, so we have various projects which are all in line with current trends in electronics. So we are developing a food scanner which would show protein and fat on your smartphone. So you scan some food, let's say bread or some fruit, it will tell you how much protein is there, how much fat is there. Then we are working on one sensor which would tell you the type of textile what you are wearing. So it is basically for a washing machine. So you can imagine that before you put clothes in washing machine, it would tell, yeah, it's wool or it's cotton, and then you can decide if you want to wash it or not. So this is what we are working on right now. So let's start with the presentation. So what I have for you today, let's see that. So my agenda for today is introduction, which I already gave. Then part one, I would talk about the current trends, what we are seeing in electronics, and then I have divided this in specific topics. And then second part, which I want to specifically make young students aware about this, like how Europe presents you with opportunities to pursue your career as an electronics expert or engineer expert, I would say. And then Germany, because I studied in Germany, and how you can come to Germany for your higher studies. So let's go to the next slide. So to start with current trends, I would like to make you aware about the Moore's law. I don't know if you have studied this or no. So Moore's law basically states that the number of transistors on any integrated circuit like IC, it doubles approximately every 2 years. So this is the graph I have for 20 up to 2018. You can see a linear increase, but at the end where I've marked it in a red circle, you can see that it has started to saturate, and in 19, in 20, and when we go up to 2025, it's going to be a flattened graph as the industry expects it now. This is because we are at the limit of electronics designing now, and this gives opportunities in new fields which are yet in research and development. Some are already working on products based on this. So those fields are material sciences, electronics design, then devices, and then innovative sensor technologies, because we are all surrounded by sensors nowadays. So this was the briefing on why we need to go ahead and not stop at the normal Bachelor of Engineering. Let's talk about material sciences for now. So as I mentioned, we are at the limit of miniaturization. So we cannot make transistors smaller, or rather little less, but not uh, apart from that, we have no other choice. And this creates problems in heat dissipation. Like you can imagine, I would constantly talk about an example of smartphone in this. So you can imagine, like smartphones are becoming very thin now, and sometimes you might have experienced that battery heats up and smartphone heats up. So there is no room for heat dissipation, and that's why there is new subject which is coming right now, that is spintronics. So electronics basically works on motion of electrons and photons. So we haven't yet used the spin of the electrons, and this is what they are trying to use now. So instead of moving electrons, they are using a flip of electrons, which is called a spin. Then until now, we were just working with silicon material as a base material for transistors or any other electronic component. But with silicon also there are few problems, and that's why they are using this spintronics of materials such as gallium nitride, gallium arsenide, zinc, and then there are spin transistors. So this is a hot topic now, and a lot of research is still going on this in this direction to come up with new ideas on how to get into smaller components. Then further miniaturization requirements have resulted in rolled up electronics and printed electronics. Like you can imagine, instead of a hard PCB, the PCB is let's say a rubber kind of thing which is very flexible, and then electronics is printed on that. And I have put one video here which you can see. Actually, it is about a printed electronics demonstration. Okay, so what is this? Basically, this is a normal packaging box, and they have printed electronics on that. That is LEDs, transistors, batteries, everything is printed on this. So you cannot really feel the electronics. And this company, which I have mentioned here, Saralon GmbH, it was started by one of my friend who was studying in TU Chemnitz with me, but in another course. So this is also a trending topic. In future, you can maybe imagine a car with some printed sheets inside instead of lamps, and maybe few posters which glow on some action and things like that. So this is a trending topic currently here. Then coming to the second theme, let's talk about electronics design actually. So when I was in my bachelor's, we were always talking about some ASIC development or VHDL, VLSI, then PCB design, but I was never aware like what to do with this. And then when I'm now working in one high-tech company, we can see that ASIC has a lot of potential. So what is ASIC? It is basically application specific integrated circuit. So you can imagine, if you have one sensor and in your projects you use some transistors, you use some wires, you use some LEDs, op amps, and then make a PCB out of that. So ASIC is nothing but everything put in one chip, which you can see here in image. And this is going to be the future now, like putting complete electronics on one IC. And for this, you need expertise in languages such as VHDL, then tools like Cadence, and normal programming like C++, C. And I'm aware that in bachelor's, even I didn't study this. So masters or higher education, you need for this expertise. And yeah, one of my bachelor mate, he's going to give lecture on this in the same series. So you will definitely enjoy this. Then when you have a ASIC now, the electronics around it should be also low power consumption electronics. It should also create less noise, which will give you a fine output. So this is also comes under expertise of electronics design. Then we have learned to design PCBs, but I'm pretty sure that no one has designed a 16-layer PCB in bachelor's. And when you are working in a high-tech company like ST Microelectronics or Nordic Semiconductors, then they are already always designing this kind of PCBs, which are 16 layers or 8 layers mixed signal PCBs. So you need some expertise in that, and there are very less people who have this kind of know-how, this expert know-how. Then coming to the next topic, which is devices. So right now, when we say electronics, it is just some op amps, some transistors, some kind of electronic chips. But no, electronics is further beyond that. Now, when I say this, I'm saying that electronics is nothing but now micro electromechanical systems. Like here, the image which I have put, it is a micro mechanical system, which is nothing but an accelerometer of gyroscopes kind of structure which you have in your smartphone, but it needs electronics to run, and it is again development of mechanical system along with ASIC integrated. So you can imagine what opportunities it gives you. Like you can be an expert in something and you pursue your career in that direction. Secondly, energy harvesting devices like thermovoltaics, piezos, etc. These devices are under research now to create battery-less smart devices, like for example, smartwatch or smartphones, or you can imagine a sensor to detect soil moisture or pH in farms. In India, we can imagine the farms are very huge and we have electricity problems. So you can imagine a sensor installed in a farm which is working on photovoltaic effect, thermovoltaic. So work basically storing the energy from sun and using that energy. So these kind of devices are under development now. Now, once the devices are ready, we also need to have a reliability and robustness of these devices. There comes the part of failure analysis. So you can imagine, let's talk about a smartphone. When I'm designing a smartphone, let's say, I would always have a feeling like, yeah, I want to make a best smartphone which would run for 10, 15 years. No, the companies, they want that consumers buy a smartphone every 4 to 5 years. So they want the system or the electronics inside to fail after 4 and 5 years. This is how you will design a failure analysis curve. Like you start using device and now at certain point, I want to fail this device. There comes the study of failure analysis. Then comes physical characterization techniques. Like you have now designed some ASIC, let's say, but you don't know if I throw it from a third floor of the building, if it will still be working or not. And do you want to keep it working after third floor? And then comes this techniques called finite element simulations, microscopy, then packaging reliability, and other tests which are related to this. Also important is electrical analysis like the VI characteristics, tolerances, heat dissipation, the noise generated, etc. etc. So what I want to say is electronics, it's not just programming an embedded system or designing an PCB. It is more to this. That is the reliability and robustness and failure analysis of these devices. Coming to the next topic, integrated smart sensors. This is the field which I'm working on currently. So as you can see on the right hand side, there is a image of a ST sensor, smart multifunctional sensor. So as you can see, this one chip, very small chip, it has a MEMS motion sensor, which is an accelerometer, then a temperature sensor, then a Bluetooth module, then a Wi-Fi module, and the electronics to run. So basically you put this chip and then you get a signal output maybe on Bluetooth. This kind of miniaturization needs some expertise. And you as fellow graduates, I would suggest to pursue such kind of career line because there are less people in this field who have this kind of know-how. Now, when you have this kind of devices ready, they should be less power consumable. The PCB or the chip should be highly scalable. It should be reproducible. Like the same readings should, every chip should give same readings, and the electronics should be reliable. That is, if I throw from a third floor, it should still work if I want to design the system like that. Next, now I told you about what we are working now on a food scanner, let's say. So I don't want my smartphone, which is having this food scanner, to connect to the cloud always. So I want this machine learning thing to work on my smartphone. For this, there is need of smart chips. I'm talking about ST and these Nordic companies. They are already having some kind of chips which you can program machine learning on that. So until now we have seen smartphones. You type something on Google, next time Google is giving you recommendations regarding that. So this works on cloud. But what we want now is to have this machine learning running on your devices. And examples of this is autonomous cars, smartphones, IoTs. Everywhere you are going to see this in future. So these are the current trends, basically what we are seeing now in the electronics industry in general. Coming to the work profile, like I told you what are the trends. So but what profile defines this? So you did engineering, either bachelor or master or whatever. So you can work as an electronics design engineer. It could be an analog designer, digital designer, mixed signal designer, or a specialist in ASIC development. Like there are ASIC warehouses which are only doing this kind of job, ASIC design, and they need experts in this field. Then secondly, I was talking a lot about reliability and failure. So this is where process engineers, reliability engineers, test development engineers come into play. So reliability, I already spoke about. Process engineer, basically, there are certain processes that one electronic chip has to pass so that it's sellable. And who decides these processes? It's the job of process engineer. It cannot be like someone is designing a chip and now I can sell. No, it should pass through a process engineer through his process steps. And then the test development engineer, his job is to design a test which a process engineer would need to pass his processes. This is a complete package and it's highly multi interactional. Then coming to the software side, you have a firmware engineer which is expert in firmware development, so basically embedded systems. Then you have automotive software engineers. In automotive they use different kind of softwares like ADAS and uh, some electronic development boards. So for that they have specialist know-how. Then robotics, for robotics one might need a real-time operating system expert or C++, Python expert. But this is again based on electronics. Like you design a robot, but it should be designed so that the robotics engineer could program it. You cannot just put something and give it that, yeah, now program. No, it won't work like that. So it's always multifunctional. Then data science engineer, what I told, like machine learning on PCB at C level. Like I have seen few demo projects done by students. They use Python packages, ready-made TensorFlow packages, and they implement machine learning with that. But no, when you want to implement it on a PCB level or a microcontroller level, you will have to program it in C language or C++ for that matter. So you need machine learning specialists. Okay, so this was about the current trends and what profiles would lead to this. So now I will start with the next part. Like if you want to be an expert in engineering, how to approach this thing. So a way ahead. Now this flowchart is just a schematic showing how you can go there. So you did your bachelor's, then you start as a graduate engineer. Then maybe you can do a MBA, then you take a management route and go to higher positions. Or if you are if you are an engineer and you want to be expert there, you can spend 5 7 years, earn expertise, and then become an expert engineer. Or what I did a technical master, and then I'm working as an expert, and then I can go in higher positions by becoming a team lead or project manager and whatnot. Now I have seen this as a trend for last 7 8 years. Like when I was in my bachelor's, everyone was talking about GRE and going to US. But I decided to come to Europe. One reason was, yeah, my cousin was here. He made me aware of this. But if you don't have anyone, yeah, then why Europe? So then I have few points which I would like to tell why Europe. Here you get state of the art as well as future oriented curriculum, and you have direct opportunities after studies. Like I already told you that here they lack good engineers. So if you do engineering and a good quality engineering, if you are a talented engineer, it's very easy to have an opportunity after studies. Then the studies here are research and development oriented, and they work in close cooperation with the industries. So when I was doing my master studies, I worked on a project like final semester project, and I was working with one company for this project, and this company is going to come up with this project product idea which I was working on after 5 years. So that kind of industry cooperation the universities have. And then where you can study in Europe, Germany, Switzerland, Netherlands, and Scandinavian countries like Norway and Sweden. These are the best technologically established countries. Other advantage of being in Europe is you are in a highly multicultural environment. Like you can imagine that you are surrounded by students from various European countries as well as Americans and South Americans and other parts of the world. Yeah, so you can get in line with their thinking, and this boosts your personality very strongly. And last but not the least, the studies in Europe are quite cost efficient when you compare with costs in US. And then after a master's year, it gives you a very good opportunity to start your PhD in Europe itself. And by cost efficient, I mean that if someone spends 30 to 40 lakh rupees in US, in Germany you will have to spend maximum of 5 to 8 lakh rupees in Europe. So that's a very strong point here. Then coming to next slide, like now we talked about Europe, but I would still like to mention Germany because I did my masters here and there were few reasons and also my points I would like to put why Germany. So first and foremost, it is one of the best technologically advanced countries in the world, and it is a safe country. Like you might have been aware of few incidents of lynching and criminal incidents in Australia as well. Same is happening in US, but in Germany there is no such problem. So it's very safe. Then the universities are world reputed, like Stanford and Carnegie Mellon in US. Here we have TU9, that is IITs of Germany, and they are really good. And the engineers coming out of these universities get jobs in highly reputed companies as an experts. Then, as you know, Germany is a technology hub for industries like Bosch, Infineon, BMW, Mercedes, Siemens, BASF, and etc. So when I say BMW, Mercedes, it's not just mechanical engineering where cars are designed. The cars in Germany, the design in Germany is highly electronic oriented, like infotainment systems, then autonomous systems, safety systems. They are all electronic based systems. Next point, as I said, the education is very cost efficient, but in Germany, you have an advantage that the universities have very less tuition fees, or some universities have no tuition fees. And after the education, they offer you a job search visa of 18 months, which is a very plus point here. And when I say no tuition fees, that means that you have some $250 of per semester fee, which is for registration and exam. And the reason for this is they want students from all over the world to come here, get educated, and work here itself. So because they are lacking engineers, so Indians can make a good deal out of this, which I have experienced. Then next is here it is possible to cover all of your expenses working part time. Like you can get a job in university, or I worked in one company as a work student. Few people work in restaurants, and it's very easy to cover the expenses working part time. And last but not the least, Germany offers excellent work life balance, and no, or sometimes yes, but usually there is no work on weekends. And also now during this COVID, you might have seen on LinkedIn there were thousands of posts that I'm jobless and I'm looking for opportunity for last 5 months or so. But as far as I know, in Germany, uh, it is very difficult to fire someone off the job, and even in these hard times, people were still working. I was also working, and even if few people were on part time, they were supported by government as well. So in all, it's a good option here. Now, what are the prerequisites for masters or MS in Germany? As in US, here GRE is not required. As far as I know, only 3 to 4 universities need GRE. Then TOEFL and TOEFL and IELTS, these exams are sufficient. Then relevant work experience is valued here. So I would suggest that after bachelor's, you gain 1 or 2 years of experience, you understand what you want to study, and then you can pursue your master's. In the meantime, if you learn German, it is a very good advantage for you because as we in India speak our own language here, Germans do speak their own language, then it becomes easy to interact socially. And then for further help, I have posted these two links. I ask you students to note these links and yeah, have a look at these links. First link is about the courses and offers in Germany, and it's a very good website. They have mentioned, for example, for particular course, how much fee is needed, what are the deadlines, what are the requirements, etc., etc. How much is the living cost in that city. And second is about why to study in Germany and what to study in Germany. So I strongly recommend to look into these links. And third, next point, what one can study here. So as we all know that embedded systems is electronics cannot work with embedded systems as of now. So there are specific courses for embedded systems. Then automotive software engineering, it's also a hot topic which electronics engineers can pursue. Then if you want to go on the hardware side, this is the course what I studied, where you study about microelectronics, MEMS, nanoelectronics, then manufacturing technologies, where you study about reliability, fabrication, and those processes. Third, if you want to look into system side, there are photonic systems, optoelectronic systems, micro-optical systems, then biomedical systems. Of topics you also pursue on the list. If you are really interested in working on the data side, you can go into image processing, data science, machine learning, and few other topics that you might come across while searching for the universities and courses. I hope this this seminar has motivated you in some or the other way. And for any questions, you can contact me on the email address which I provided, and Kumbar sir might share my contact as well. So yeah, that was from my side. And thanks for your attention. If you have any questions, you can feel free to ask.
Students, those who have question, please tell your name first, then you can ask the questions.
Hello.
Hello?
Am I audible?
Yes?
Hi, my name is Nitin, and I have some questions regarding education in Europe.
Okay.
So, first of all, first question is that all public university gives scholarship in Germany or Europe?
Uh, so public universities, basically most of the public universities, they don't have any tuition fees, like I said. So public universities, like let's say the university where I studied, TU Chemnitz or TU Munich or KIT, there they don't have any tuition fees at all. So scholarship doesn't come into picture. Like the fee which I was paying was 250 euros per semester, and that is around, let's say, 30,000 rupees per semester. That's what I was paying. So you don't need any scholarship there. But whereas there are some universities, they have started with tuition fees per semester, and then you need to apply through some portals for scholarship, and then they decide on the merit, your experience, your expertise, and what you can bring to Germany. Then they can decide if they want to offer scholarship or no.
Okay. Then, is there internship culture famous there, and why they prefer
Yes.
internship?
Yes, internship culture is highly recommended as well as yeah, companies welcome this as well. So the masters in Germany, I can tell you, is at the in the last semester you have to do master thesis. So which is a project that you do in your final engineering as well. But here the difference is you work by your own on this topic, either with company or in your university, and then you go ahead in this topic. So before this thesis, so I did my thesis in a company. So before a thesis, usually company offers you internship as well. So you get an idea about the work culture in the company, what are the topics that are happening in the company, and then you can do your thesis. This is one way. Or second, people just do normal internship as well. And the advantage this gives to the company is that there is always some kind of work which is repetitive or which doesn't need that high know-how. So once you can teach to someone and then they will do it. For example, I had recently one working student, that is internship. He was working for 3 months, and his job was to design one evaluation kit. So I told him, so look, I need one this kind of evaluation kit where I have to put two sensors which are manufactured in our company, and they should give a voltage per time output, and then I should be able to calculate the frequency transformation of that. So what he needs basically is a voltage divider, then an op amp, then parallel four op amps, and this kind of circuit. So I explained him, and then he can take his time and design it. So that's one way how we perceive internships, and advantage that you gain a good know-how on some kind of technology in the company. Have I answered your question or?
Yes, yes, sir.
Yeah, so internship is highly of importance here in Germany.
Okay, I heard about you talking about the part-time job.
Yeah.
So also I got digging out in the website. They offered you only 20 hours working in a week. So that might be affects in our day-to-day life. Means there is a college hours and part-time hours.
Yes, it depends on you. So, I mean, no one is forcing you to work part-time. So it's maximum you can work 20 hours per week. You can work 5 hours, you can work 10 hours. It depends on you and how the company or the job your employer is dealing with that. But I can say that 20 hours a week is 4 hours per day, including Monday to Friday. So yeah, you can easily manage studies with that. I mean, it's not that difficult.
Okay. One last question. Uh,
Mhm.
what university prefer for getting admissions there? Means an academic marks or any extracurriculum activities, or they prefer both simultaneously?
It depends actually. Like marks are definitely preferred. If you have German language, that is definitely preferred. If you have a relative work experience, that is definitely preferred. But yeah, it's always a trade-off. Like one might be a topper in university, but let's say he studied computers engineering, he topped there, and now he's applying for a course which is in microelectronics. So why I should consider that guy? So it's always a trade-off. But after computers, he worked in one electronics company and maybe worked on development of tool like Cadence, then he might be preferred there.
Okay, sir. Thank you.
Yeah,
Hello, sir.
welcome. Yes, hello.
Sir, I have one question. In fact,
Mm-hmm.
most of the students here are local. They don't have that much exposure of studying in Germany and all that. So,
Right.
as a first step, what they should be doing, in order to prepare in that direction, students should be doing.
So I would suggest first step would be to look into those two links what I gave you. Like first check out the link why to study in Germany and read about read about the articles by some students, like there are blogs on internet or YouTube videos, like how it is to study in Germany. So let's say now you have decided that I want to study in Germany. So then next step would be, I like what I did was, once I decided to study Germany, I enrolled myself in a one German class. I started learning language. Then parallelly, I started looking for courses. So in this website which I have suggested, you can type keywords. Let's say VLSI. Then there would be courses showing VLSI engineering or related to that, and which universities offer those courses. So you can go on that link, check like XYZ is a course, what are the contents of the course? Am I willing to do this? If I want to really pursue this, and then see like the what are the requirements. So some might have a requirement like, yeah, you need a TOEFL score, you might need a IELTS score of 8 or 9, so you will have to prepare for that in accordance. Then get in contact with few people in that field. So I have requests coming from India, like about my course which I did in Chemnitz. How is the course? What are the opportunities after that? So talk to people and then decide.
Okay, sir. Thank you. Yes, any other students? Any queries, questions from your end?
Hello, sir. Can you tell me some few tools that students should use to enter into VLSI or MEMS? Any tool that we can use
uh
or can
yes,
know?
for VLSI I can just tell that Cadence or VHDL language, it's of help. But for MEMS, so I had this course of MEMS. So there basically what they use is ANSYS programming, and it is a very handy tool which gives you quite a lot of opportunities being an electronics engineer or mechanical engineer, where they study about stresses, strains, and how the structures should move. So ANSYS is one tool. Then MATLAB is highly used for analysis. Once you export data after ANSYS, MATLAB or Python, that is used a lot nowadays. I can definitely recommend students, every student, to learn Python, because Python is everything. You can do anything in Python. Like I'm using it every day, and many people in my company also use Python for data analysis, evaluation, and this kind of purposes.
Okay. Other students, feel free to ask the questions. If any doubts are there, ask your questions. पूछना.
Hello, sir.
Yes,
It's
hello.
the faculty from ETC department.
Hello.
Sir, you said about the cadence use of in Germany also.
Mm-hmm.
Like we have the purchase tool of cadence in our college only.
Mm-hmm.
Recently, we have purchased in the last year. But I
Okay.
wanted to know what bundle of tool is required for the students for learning. Like actually, it is not been given to all the students at this point.
Okay.
It is
Okay.
there for only like ChemTech students and for the research for PhD scholars. Okay.
Okay. Okay.
So we wanted to do it for even third year and final year students also.
Mm-hmm.
But provided many of the faculties are not exposure to that. even at this
Okay.
point also. So, what do you feel like where we should start? Like some basic, some tutorial kind of activity
Actually,
that can perform to the.
I I myself haven't worked on cadence, so I'm
Okay.
not the right person to answer this. But in your next seminar,
Yes.
Rejoy Matthews,
Yeah. Yeah.
he
Okay.
might be able to answer this question of you.
Yes. Yes. No problem, sir. No
But
problem.
what we had in our course is
Hmm.
VHDL programming, so that you can
Yes.
definitely start in your course.
Yes. No,
So
no, that is there already. We have many of
okay,
the semesters we are conducting. You are using Xilinx, Vivado tool and all.
Xilinx exactly.
So, yeah. Even you said about these MEMS that you are working and sys that you
Yes,
have used.
yes.
Okay, sir. Even I have some PG projects also on
Mhm.
these MEMS actually, MEMS design and all. So
Yeah.
we have used the Coventerware. That is also paid tool which we
Mhm.
had in our college. So
Okay,
I
okay.
use. So how that tool variant in that MEMS design? How like what will be the differences like Coventerware tool, ANSYS tool, and many other IntelliSuite? These are I heard like they will
Actually,
be
like
used for MEMS design.
from my experience, I can tell like we
Mm,
studied ANSYS, but one of my
mm.
colleague he is working on MEMS design, but he's using some other tool. So for
Okay.
him, it was not a big problem switching from one tool to
Okay.
another. The basics should be clear, like stresses, trends, how to see
Yes.
those things,
Yes. Yes. Yeah.
then fluid analysis. If these things are
Okay.
clear, then I don't think it's a problem from moving from one tool to another.
Okay, sir. Okay. Even this exposure to the MEMS is very less in this area, sir. Actually. So,
Yes.
what could be some basic tools like some mini projects kind of a activity that we can do for our students? Like what you suggest on that
I
for
can
the MEMS
definitely.
design and.
Yes, for the MEMS design, I can
Mm,
definitely recommend what. So when I studied my masters,
mm.
everyone was first time introduced to the MEMS.
Okay.
So we had one project throughout the semester, like parallel to this subject, a
Okay.
complete coursework where we had to design one accelerometer.
Yes, sir. Yes, sir. Okay.
So right from starting the main block of the accelerometer, then designing the
Mm.
walls, then putting
Yes, sir.
stresses, strains. So that was our complete project. And this is
Great.
a very simple structure, like one moving plate in between, and then
Yes, sir.
four walls, and then you can
Yes, sir.
design the edges as per your need. So that you
Yes,
can
sir.
start.
Okay. Okay.
Mm.
Okay. Actually, I did my PG in that only. That's why I'm very
Okay, okay.
curious about
Mm.
it.
Mm.
So I also designed the capacitive accelerometer only
Right, right.
in my PG using Coventerware.
Okay.
So many times I heard it from my HOD related to this to conduct some activity for the students, but
Right.
due to unavailability of the tool, I couldn't do that. That's why I
Okay.
was posting some questions here.
I think
So,
ANSYS has one free version for students.
okay, sir. Okay.
I mean, we had used it, so it should be still available.
If you have any detail about it, can you share it to us, sir, so that we
Yes,
can?
yes, yes, I
Okay.
can share, and maybe I can also share the slides
Okay,
from my MEMS course as well.
okay, sir. That would be much helpful. Okay.
Yes, that I can do.
Th-
Yeah.
Okay. Thank you, sir. Thank you very much.
Thank you.
Any questions, students? Okay, fine, sir. I think all the doubts regarding these are clear to the students.
Okay.
Thank you so much, sir. Your input will be definitely helpful for students as well as the faculties over here.
Yes, thank you very much, and feel free to contact me anytime on my email address regarding any information.
Sure, sure, sir.
Yes.
Now I would request our faculty VB Kumar sir
Mm-hmm.
to present vote of thanks.
Yeah.
Thanks, sir. First of all, I would like to thank you, our beloved director, Professor P.V. Kadule sir, and head of our department, Professor Dr. L.S. Admute madam, for encouraging and supporting to arrange this webinar. On behalf of our institute, I would like to thank our today's speaker, Mr. Sourabh Kulkarni sir, for readily accepting our invitation in such a short notice. Our students have definitely benefited with your inputs. We hope for similar association in the future as well. And the last but not the least, all the students who are attending this webinar. So I request all the students to unmute mic and give big round of applause to the speaker.
Thank you. Thank you very much.
Thank you, sir. Thank you.
Thank you,
It's a
sir.
very nice presentation.
Yeah, I hope it helped
And
the
everyone,
students.
yes, sir.
Yeah, I hope that it helped the students and they can definitely contact me in case of any queries.
Yes, sir. We will be in contact with you.
Yeah. Thank you very much.
Okay, fine. All the students, tomorrow sessions will be at 10 a.m. So I request you all to join 30 minutes early. You may all leave now. Thank you so much.
Thank you. Should I sign off, sir?
They are still there, but they're about to sign out.
Yeah.
Thank you,
Okay,
sir.
bye. Thank
Thank you.
you.
Bye.
Bye.
ये ये बढ़िया किया आज.